Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 3.3.1. Our M&Ms for this homework have to do with fraction division. And in our lesson, we learned that there are a few different processes that you can use to divide fractions. Some of them, like using the diagram, I've never found this easy to understand. So my recommendation, I can't remember ever teaching a student that thought this was the easiest method for them to use. So I am not going to focus on this too much. I like method 2 and method 3 a lot. Method 3 is the most common way of teaching, but method 2 does work. Since you are already used to finding common denominators when you add and subtract fractions, you can actually do that when you're dividing fractions. And what happens is once you rewrite 2/5 as 4/10 and you do the division, it turns out that all you have to do is do the division problem with the numerators. Because what is going to happen here is 4/10 divided by 3/10 is going to end up giving you 4. Nice, stop it. Going to end up giving you 4 divided by 3 as a fraction in the numerator, and in the denominator is 10 divided by 10, which is equal to 1. So we don't care. Anytime we have a 1 in our denominator, we don't need it to be in our denominator. So it's like having a number 5 over 1. Why just write it as the number 5? You don't need the denominator when the denominator is the number 1. So it's based on that idea that we could just get rid of the denominator and just focus on the numerator. So 4 divided by 3 can be rewritten as 1 1/3. So that would be the answer. And I actually do have quite a number of students that once they see this, they're like, oh, I think I like that. That makes more sense to me. Because with with method 3, where you use the supergiant one, this is basically multiplying times the reciprocal, right? So 3/4 divided by 2/5 gives you this if you write it in fraction form. And if we want to change the denominator into a 1, we have to multiply it times its reciprocal. But you can't just multiply the denominator times the reciprocal without also multiplying the numerator times that same reciprocal. So notice how you're going to get 2/5 times 5 over 2 is going to give you that 1 in the denominator, and we don't need that 1 in the denominator, so the numerator becomes our problem. So this is the justification for why you are allowed to change a division problem with fractions into a multiplication problem where you keep the first fraction the same, but you multiply times the reciprocal of the second fraction. There's some mathematical logic to it, if you will. No, mathematical logic that explains why we do it, but most of the time we skip all of this and go directly from here to here. And it works. So as long as it works for you, go ahead and use that method. And let's go back to this. When we're asking the question, how many 3/10 can you fit into 2/5? You can fit one of these plus another 1/3 of them will fit into there. So let's look at this for a second. If I take an entire 3/5 or 3/10 plus an additional, what would be 1/3 of 3/10? It would be 1/10. So when you combine those, you get 4/10, which is the same as 2 over 5. How many of these can you fit into there? 1 1/3 of those will fit in, right? Here was the 1, and here was the 1/3. Once again, can be a little bit confusing to think of it in those terms. So if you just remember the process, either find common denominators and do the division with the numerators, or multiply times the reciprocal. Both of those are effective strategies that are not too hard to remember. So let's take a look. Problem number 93 is just taking integers, right? Complete each of the following division problems by first rewriting them as a fraction. So I guess what we should have done is started by saying this would be -6 over 8, and now you simplify the fraction to -3 over 4, which in decimal form is -75/100. Same thing applies here, but now you've got the negative sign in the denominator instead of the numerator. Okay, so now's the time we have this discussion. Does it matter if the negative sign goes in the numerator or the denominator? And the answer technically is no. Just like it wouldn't matter if you had negative 6 divided by 8 or 6 divided by negative 8. A fraction is just a division problem, so it really doesn't make any difference if the negative sign's in the numerator or the denominator. Either way, when you do the division, you're taking a positive divided by a negative, so you get a negative answer, and the decimal equivalent for 3/4 was 75/100. So either way, you're going to get the same answer. Great. Now I'm going to ask this question again. How many 8s can you fit into the numbers 0? And the answer is none. Why? Because if you were to use your multiplication families, 0 divided by 8 is 0 because 0 times 8 gives you 0 for an answer. So 0 in the numerator gives you 0 for an answer. But when you go in the other direction, 6 divided by 0, if you were to use the fact family, 6 divided by 0 equals 0, that's the most common answer people give for it. And that must mean that 0 times 0 has to be equal to 6. And that is absolutely not true. It doesn't work. And so then people think, oh, well, then the answer is 6. Let's try that. Okay, let's see. If we say 6 divided by 0 is equal to 6, then that means that 6 times 0 is supposed to equal 6. And that doesn't work either. What is going on here? Well, what is going on is this is not allowed in mathematics. It is considered undefined. Now, let me explain this. The number 8, how many 8s can you fit into the number 0? The answer is none. You can't fit any 8s into the number 0. So your answer is 0. How many 0s can you fit into the number 6? Can you fit 1? Can you fit 2? Can you fit 100 million of them? Whatever you multiply times 0 is always going to give you 0 for an answer. So there's an undefined number of zeros that you could fit into the number 6. It's beyond infinity. There is no exact number that you could ever multiply times 0 to give you 6 for an answer. So that's why the answer is undefined. And whenever you have fractions with 0 in the denominator, we can't do that. That is undefined. You can never have 0 for your denominator. All right, so let's get into the processes. How do we divide fractions? Do you want to find common denominators, or do you want to multiply times the reciprocal? I think most of you probably will want to multiply times the reciprocal. Now, I would like to draw a picture of this. I love drawing pictures to represent these situations. Oh, no, that's not going to work very well, because I have to break this up into 1/6 pieces, and no, forget it. No picture for this one. So what do you multiply times 1/6 to give you 3/4 for an answer? I don't know. Let's work through the process. Instead of dividing by 1/6, let's multiply times the reciprocal of 1/6. That gives you 18/4. And 18/4 can be simplified by dividing the top and the bottom by 2 to 9/2, which then gets written as a mixed number. How many 1/6 can you fit into 5/12? Well, it turns out it's 2.5 of them. But let's not draw the picture of that either. Let's just take 5/12, and maybe this time I will find a common denominator and change that. No. -2/12. So now we're just going to focus on the numerators. 5 divided by -2, 5 divided by -2 is equal to -2.5. So you get that answer, and it works just fine. Had you decided to multiply times the reciprocal, you would have said 5/12 times -6/1, and that ends up giving you -30/12, which can be simplified, and will simplify down to -5/2. And like I said up here, it really doesn't make any difference if the negative sign is in the numerator or denominator. Once you convert it to a mixed number, it'll just go to the left of your number. If anyone wants me to solve C or D, let me know. It's pretty much the same process, just different numbers, and here you'd want to change that to an improper fraction first before doing the division. All right, 1/3 of a rectangular playground is designed for young children. In that part of the playground, there's a structure that covers 2/5 of this space. So in essence, what we're doing is we're trying to find out what is 2/5 of 1/3, or what is 1/3 of 2/5. So if I take a rectangular box that represents the entire playground, 1/3 of it is for children, and 2/3 of that section is meant for the children's play structure. How much of the total playground does this section right here represent? Well, that would be 2 out of 15. And so that's the answer. And if you multiply 1/3 times 2/5 or 2/5 times 1/3, doesn't matter which direction you go, you get a 2 in the numerator and a 15 in the denominator. So our answer, after multiplying, matches what the visual looks like in the rectangular unit, in the unit rectangle. That's what we call those things. So let's see, what fraction of the total playground is the play structure? 2/15 of the total playground is the play structure. All right, I love integer tiles. They just help us understand these integer operations so much. If you take -6 and -2 and add them together, you get no zero pairs. They just get added together for a total of -8. And if you take -6 and you want to take away -2, here are the -6, there go the 2 negatives. What are you left with? 4 negatives. If you wanted to do KFC and prove it that way, you could rewrite this as -6, flip that to a plus sign and change that to its opposite. And now the diagram would look like this. -6 plus 2 leaves you with 2 zero pairs. Go away on their honeymoon, and you're still left with -4. So whether you choose to illustrate this as a subtraction problem, so taking away negatives, or you choose to use KFC and change it to an addition problem, either way will give you the correct answer. They both give you -4 as your answer. And now for the last part. If this line segment at the right is divided into equal parts, right? That's equal to this, which is equal to that. And there are a total of 1, 2, 3 parts. You're breaking the number 75 into 3 equal parts. What is 75 divided by 3? 25. That means your counting sequence must be counting by 25. Now you could write it this way, or you could say, well, this is 25, and this is 25, and this is 25, right? Well, at this point, you've added 2 25s together, which is why this number is 50. And at this point, you've only got 1 25, so that's why it's 25. And at this point, you've got 3 25s, which is 75. So these two combined must be equal to 50. And that's our answer for that portion of the line. Ooh, do I want to do this right now? No, I do not want to do this right now. I don't think I want to do that right now. I don't know. Maybe that's what your assessment's going to look like. All right, so we have drawn this to a conclusion. And it is time to move on to our next activity. Take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling